Stepsters. I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today we'll be looking at constructing geometric figures. So there are many parts to this video, so make sure to pay attention because each and every one of them is really important and helps you build your own geometric figures.
So let's get started. So we're going to start off with talking about a few basic tools that we use for constructing geometric figures. So let's start off with talking about the main tool, which is our compass. So our compass is used to draw circles and arcs and to also copy lengths. So this is how our compass looks, and if we ever had to use it, we would just measure it up to a certain radius. So whenever we're making a circle, the distance from the top of the pencil to the pointy part is our radius. So if we ever have to draw a circle with like a radius of 4, we just have to place both of them, one at 0 and the other at 4. And then we can draw a circle with a radius of 4. And then a straight edge is used to draw straight lines and extend them infinitely, but not to measure lengths. So a straight edge could be, so since it's going to take us to infinity and we really cannot draw anything to infinity, we usually use arrows at the end to show infinity, but to make a line, you could use a ruler, or you could also use these things, and these are called, here, let me pull out the other one real quick. So you can use, every single geometry kit comes with two of these, and these, we call them set squares. These are used to draw straight lines, and they're almost like a ruler, but you can see that they aren't rulers. Okay? So now we talked about the compass, a straight edge, and a set square. We also have a protractor, which we use to draw angles. This is our protractor. Simple, it has all the angles. It also has measurements, so pretty simple. Now, for our little drawing kind of thing here, we're going to be using a compass and maybe a protractor. We're probably going to use a protractor to get the angle. And then we will need a straight edge, so a ruler or a set square, either one of those. So we're going to start off with drawing a line. So I'm going to take, let's say, a, let me have a measurement here. Let's say I want something like, that's 6 centimeters, right? So that's our line. We are trying, here what we are trying to do is we're gonna try to make a perpendicular bisector. Now, a perpendicular bisector is when we construct a line that cuts another line segment. So this is our first line segment, right? Because it ends at 2 points. And every perpendicular bisector, it basically cuts through another line. It's a line that cuts through another line at exactly 90 degrees. And when it cuts through, both the sides are going to be equal. So let me take my compass real quick. And this is how you make a perpendicular bisector. So here is my compass, right? We're going to have the pointy edge at one of the ends of our line segment. And then you kind of just draw a simple little arc. My compass doesn't work very well, so we'll have to go with that. And then you do the exact same thing and make sure that you don't adjust this so it's the same. And then you place it on the other end and draw an exact mirrored image of the arc. Okay, my compass will not stay. Sorry about this. Okay, so that is our two mirrored arcs, right? Now you see that there is an intersection right here, right? So all you have to do now is take a ruler, or maybe take a straight edge actually, because they have a 90-degree angle, and make a line from this intersection to wherever it intersects the line. So because we use a straight edge with a 90-degree angle, we know that both of these sides are 90 degrees, and these two should be equal to each other because we made sure that the arc length is going to be the same, and they were from two ending points of the segment. So this is our perpendicular bisector. Now if I erase these arcs, you're gonna clearly see a picture of something that looks like an upside down T. That is a perpendicular bisector because it's perpendicular. And I'm pretty sure you guys have heard about perpendicular lines and all of that earlier, so think of this as the same thing, except both sides, so this length and this length, will be equal. Now let's talk about an angle bisector. So an angle bisector is where we create a line that divides an angle into two equal angles. So for this one, let's just draw another. Let me pull this back so you guys can see this. So I'm just gonna make another line, and we're gonna have something at some angle. So currently at, let's say, okay, what angle should I do? Let's go for, let's see, let's go for something like, something simple so it's easier for us to see. So I'm gonna go with, let's say 40 degrees. Okay, quite simple. We're gonna, once we make, so like you saw right now, I used a protractor, placed the middle at one of the ends. Well, probably you'd want to place it at the left end so that you can get a 40-degree angle. And then I made a line at 140, which is currently exactly at 40 degrees. And once I make that mark, all I have to do is use a straight edge and connect this to the end. So this is our 40-degree angle. Now we're going to be making an angle bisector. So let me readjust my compass so it's easier for me to make this. Okay. Yeah, we're not going to question that. Now, basically what you do for an angle bisector is you take your pointy part of your compass and stab the vertex. Make sure it's tight enough, unlike what I did for the previous one, so that it doesn't slip off, and then you just make a simple arc. And make sure that the arc intersects both of the lines and it isn't like out here. Okay? And once you do this, you just take your compass again, and this time you're going to place it at the edge where it intersects the line. So this is the first edge, right? Now, once you do that, just make an arc and then do the exact same thing on the other side. So I have this right here, and then do that. Now, you're going to see that there is a point that the two arcs intersect. That looks cool, doesn't it? So now you're just going to take a straight edge, put it where that thing intersects, and at the vertex, and connect the vertex. So now if I measure the angles, right, they should be exactly 20 degrees, and they are, look, perfect. So this is 20 degrees and 20 degrees. That's cool, isn't it? This angle will be 20 degrees, and this angle is also 20 degrees. And like you saw right now, in an angle bisector and a perpendicular bisector, both the angles that we cut through are equal. And personally, this thing, it looks pretty cool, and if I erase all of these lines that I made, all you're gonna see is two similar triangles beside each other. So that is how you make a perpendicular bisector and an angle bisector. You can also use, you can also use a protractor to copy angles. And that is, okay, so if I have a 20-degree angle here, and I want another 20-degree angle up here, all I have to do is place the end, so place the middle of the protractor on the vertex, so right there. You can see it aligning. Align it with the line, and then wherever you see 20 degrees, you just have to draw a line, draw like a mark, and then you can just join this and this. So that will be 20 degrees. That is how you copy angles. And for copying line segments, you can just get the measurement of the line segment and redraw it using either you can use a straight edge or you can use a ruler. Most people would prefer a ruler because they have longer lengths than what a set square would. And then you can copy angles, you can copy line segments. You can also make a perpendicular from a point on a line rather than just right in the middle. And that you can do by the exact same method as this, except you're going to be placing them at different places, at different points than these. And then you can also use these tools to construct triangles. And we already know that an equilateral triangle has 60-degree angles. So all you have to do, use your protractor, find so first make so you first thing you have to do is just make a line, get 60-degree angles for both sides, and then you can connect them all such that it makes a triangle. And that's an easy way to make it, just using a protractor and a straight edge. But if you do want to use a compass, then that would, for me, I would say that would just make it complicated. So you could just use a protractor, a ruler, a straight edge, and you can construct a triangle. And you can also do that by copying angles and line segments. So pretty simple. And that is all I had for you with all the constructing steps. So if you want, you can have a look at it again. That's our perpendicular, don't mind my handwriting, bisector. And this is our angle bisector. And sometimes you're going to see this written as perpendicular bisector as this, and then the word bisector. And for angle, you're going to see this and the word bisector. So that's all I have for you today, for now. And Lassie's going to take over with some definitions and teaching you some more good things.
Okay, now that we Kritika told us how to construct geometric figures using, tools from geometry for geometry. Now let's look at some geometric principles that you would need to know. So first we have the arc and circle properties that you need to know for geometric constructions. So this is understanding how circles and arcs are used to create points and lines. And you saw how like Kritika she used. Okay, let me first define a circle and an arc for y'all. So this is a circle, we all know it. And then when you have a point, and then you just have like two lines going on, and then you have like a line or like this segment is called an arc. This is called an arc. And then there are two different types of arcs too. There's a minor arc and there's a major arc. A minor arc is less than half a circle, and half a circle is 180 degrees, right? So it's less than, that's a really bad drawing. Let me just redraw the straight line. That's a half circle, right? If an arc is smaller than this section of a circle, then it's called a minor arc. And if it's more than this section of a circle, it's called a major arc. Those are the two different types of arcs you would need to know. And then this section, whenever you have something like this, and if it's shaded like that, or like they ask you what this section is actually called, it's called a sector because like it's a part of the circle, and in geometry we call it a sector. That's basically about circles, the main things you would need to know. And then now you might be wondering, I was talking about arcs and how you would use to create points and lines, right? So basically an arc, you saw how Kritika used like two arcs for perpendicular bisectors to like make a line in between them. That's how you create points in between of arcs. Because when two arcs intersect one another, they make a point, right? That point. And then when you just draw a line going through that point, it creates a line and a point together using two arcs that intersect one another. And that's how you use, and basically these arcs are nothing but two circles themselves. Sorry about that. But like these arcs are nothing but two circles just intersecting one another. And you're just taking a little portion of those circles, which are known as arcs, to make your perpendicular bisector. Even same with angle bisector, right? You were using two arcs like that to create a line, right? That was the point of intersection, and you used a line to go through it. And these two arcs, again, they make a circles of their own that intersect one another. And that's how you use circles and arcs to create points and lines. You can create bisectors with one another, perpendicular bisector and angle bisectors too. Now let's look at congruency. So these are ensuring that shapes and angles are identical in size and shape. So let's say I have an equilateral triangle. So all angles are 60 degrees, right? And let's say this is 4 centimeters, 5. Oh, it should all be 4, sorry. Since it's an equilateral triangle, all the sides will be the same too. So all of these are the same, and all of the angles are the same too. And if I tell you to draw something congruent to this triangle, then you would draw the exact same triangle. So you'll have an equilateral triangle with the same length side. So it's 4 centimeters again. So that's what congruency means. It's that these both triangles or anything. You should not only be like triangles, it can also be like angles themselves. Let's say this is 30 degrees. Then draw another angle, which is also congruent to this angle, which is also 30 degrees. It could be anything, but it just means that they need to have the same, same identities. So like the length, the angles, everything. And there's something like not mentioned here, but like you should also know it. It's called similarity. Similarity is basically proportional. So like let's say you have two triangles. Most of them you use congruency and similarities in triangles when you go to in high school. So I will like explain them using triangle terms so that it's easier for y'all. So let's say that's 90 degrees, 90 degrees. The angles would be the same, right? That's going to be 60 and that's going to be 30, right? The angles are going to be the same for this triangles, but like this one, let's say this is 5, 3, 2 triangle. And let's say this is 10, 6, 4 triangle. So basically, what's going on here is you're actually, like, if you look at it, you're just multiplying by 2 to go to the next side, right? Same here and same here. So they're proportional to one another, the side lengths. So that's when you call the triangles that they're similar to one another because their side lengths are proportional to one another and they have the same angles with one another. And then we have symmetry. Symmetry, basically, I think is really easy. It's basically if you have a circle, this is a really bad circle, but just imagine it's a good circle, okay? And then if you draw one like dashed line exactly half of that circle, this is definitely not half of that circle, but just like bear in mind, and I'm not that good at drawing, but it's okay. Just think of it being half of the circle exactly. Then this part should be exactly the same as this part. And that's when you call that these two parts are identical to each other. So this is the symmetry line, line of symmetry. Or let's say you have like a line, right? Just a line. And then you draw one dashed line in between them. Then you should know that the length of this should be the same length of this. And that's when this would be a line of symmetry. You can also do it for butterflies because they're symmetrical. If you just draw a line between the butterfly in the middle, then one side should be the exact same of the other. And that's when you have a symmetry, and then you have a line of symmetry in between them. And then let's look at something at the really last. I'm just going to take the example we already have, like here, for Pythagoras theorem. So this is a really fun theorem. I really love it. And in high school, you'll use it way more than you think. So in right triangles, the relationship between the sides is a squared plus b squared equals c squared. And this is important for constructions, and it's really easier too in high school when you know like the pairs of Pythagoras theorem and everything. So for example, you have a 2, 3, 5 triangle. So what this basically means is 3 squared plus 2 squared equals 5 squared. And in geometry, we call this big line, which is like slanted, right, of the triangle, it's called a hypotenuse. And hypotenuse is always going to be the bigger side length. So not always, but like it's going to be the bigger one. And then it's always going to be in this case. So the smaller one, so the other two, which are not slanted, squared, and when you add them, it will give you the hypotenuse. And bear in mind, like keep this in mind that this can only work for right triangles. That means you need to have a right angle in the triangle. It cannot just work for any other triangle, like equilateral triangles. No, it's not going to work for that. You should have a right triangle. And then if you check this, this is 25, and this is also 25. Um, Is it? Wait, let me quickly check. Um, oh wait, this is a 3, 4, 5 triangle. Sorry about that mistake, but it's a 3, 4, 5 triangle. And basically, if you add these two and then you have 5 squared, it will give you the same answer. So it's 25 equals 25. And you know this pair, it's called a triangle pair, a triplet. So what this basically means, you have many different triplets like this in Pythagoras theorem. So you have the 5, 3, 4 pair, and you have the 7, 12, 13, and many other ones that actually like follow the same rule. So when you add the other two, you square them and add them, it will give you the square of the hypotenuse. And these are really useful for you in the future when you're working with triangles, especially the Pythagoras theorem too. And that is it for today. We have learned all the constructions of triangles and constructions of like perpendicular bisectors, angle bisectors, the different tools and how you can use them for constructing geometric figures. And yeah, and we also learned some good geometry principles that will be really helpful later to you in high school. And hopefully you enjoy and like learned a lot from this video. And make sure if you have any questions or any like doubts or you want us to go through something else, please comment down below, or you can even email us through our email. And make sure that to never be shy. And if you do have a question, put them in the comments. We'll definitely reply to them because we check each and every one of our comments. And yeah, that's it for today.
Mm-hmm. one thing I do want to add is in the Pythagorean theorem, like Lassia said, there's something called the triplets, which we call the Pythagorean triplets, and there are four main triplets, which would be 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. These are the four main ones, and all of the other triplets just branch off of these ones, such as if we multiply, like you know how there are similar triangles, they're also they also have Pythagorean theorem in them. So if we had something like 3, 4, 5, there would also be something like 6, 8, 10. And if you simplify it, it comes back to 3, 4, 5. So every time you have a Pythagorean theorem question, you can always simplify the edges to see if they come back to one of the triplets. And if they do, then you know that it's a right triangle and it is part of the Pythagorean theorem. So no matter what happens in it, it's going to be true. So that that is all we have for you today. If you want if you have any questions, like Lassia said, comment down below. Any video requests, any comments, anything at all, you can comment down below. We look at all of our comments, so we'll look at yours too. And that is all we have for you today then. If you need an explanation for anything else, you can always just go back into the video and look at it again. Or you can comment down below that I didn't understand this very well. Is there any way I could have another explanation? And we'll likely comment your comment. So see you in our next video then. Goodbye.
Bye, Dexters.